Hi, and welcome to Citus Con 2023. We're going to talk about how to copy a Postgres database, so from one server to the other one. I am Dimitri Fontaine, and I've been contributing to PostgreSQL for a very long time now. I did create extension back in PostgreSQL 9.1. I did create event trigger in PostgreSQL 9.3. And I've been contributing to pgloader. I'm the main developer and the author of pgloader that was started as a project in 2005, 18 years ago. pgloader is all about loading data fast into Postgres, either from CSV files and in the modern versions, also from another database, just such as MySQL or MS SQL Server or other SQLite or other sources. I've been working for a while on pgauto failover too, which allows you to implement your HA solutions, and more than that, your architectures in production with PostgreSQL. And today we're going to talk about my latest project so far, which is named pgcopydb. So let's get started on today's topic: how to copy a PostgreSQL database. So if you ask that on Stack Overflow, for example, on Google, Stack Overflow, etc., your usual search engine for technical questions, the first answers are about using the template facility from Postgres. It's an interesting answer, that one, but it's limited to making a copy of your original database. In that instance, the name of the new one is newdb. But it implements the copy while remaining on the same server. And the idea is to go from one server to the other one, move from an instance of Postgres to another one, maybe of a different PostgreSQL version, maybe on a newer and shinier hardware, maybe on a lesser hardware, so that you can use less resources for the same job. So how to copy a database? Well, you could use pgdump and pipe the output of it to pSQL. And pgdump would be connected to the source database and pSQL to the target database. And because they each have their own connection string, that way you can move the data around. You might have read or heard that pSQL is not the best tool for that kind of situation. Well, with the proper setup and configuration for it, it might be good enough for smaller databases at least. But it's not very flexible if you do it that way. So if you want more flexibility around, in particular, the restore part of the process, you could use pgdump with a custom format and pipe the output to pgrestore. So then again, you're going to read all the data and the schema from the source database with pgdump and stream the output to pgrestore, which have a different connection string, a connection string to the new database, the target one. And so you stream all of the data and schema, etc., from the source to the target. So that's pretty effective. It might be too slow for you and maybe not flexible enough, but it works. It works very well. So maybe you can try that first. Now, if it's too slow, maybe you want to introduce some level of concurrency. You want maybe to copy the data from more than one table at once. It is still possible to do with pgdump and pgrestore as the base tooling for the operation. But well, then you need to choose either you are streaming or you are using concurrency. So for concurrency, you use the -- jobs command line option, as in the slide. And you need, when you do that, you need to output your pgdump data set to a file, and then you can restore from the file. So if you use dump and restore that way, you need to choose either streaming, and that was the slide with the pipe, or concurrency, and which means if you want to use concurrency, it requires you using an intermediate file or an intermediate data directory. With a pgdump, you can use the format directory, but it's the same. You spill to disk and then restore from disk again, which slows down the operations a lot. The concurrency only applies to the table data section. And so you don't have support for building many indexes in parallel, or at least not many indexes in parallel against the same table. We'll get back to that in a minute. And you're limited in terms of concurrency. The smallest unit of concurrency is going to be a table data, which means that you cannot split a single huge table into multiple chunks, each of them being worked on concurrently. A dump and restore will not do that for you. Some other limitations is that in case of an interrupt, network problem or anything, it's not easy to resume operations. It's possible to do because pgrestore offers advanced filtering solutions, but it's quite advanced and involved, let's say, to use them. And you need to verify everything that was done properly and filter them out, etc. So resuming is very not easy to do. pgrestore will not use copy phrase or vacuum, and it's a good idea to vacuum your tables after the initial copy, so that some of the workload applies to the migration step rather than the first set of queries that are hitting the new data on the target database. pgdump and pgrestore will not take care of roles or table spaces. And there are some other limitations in that area, like collations and extensions. We'll get back to that in a minute. And also, you don't have support for change data capture, which is the idea that after the initial copy has been done, maybe some new rows appeared, like insert, update, delete traffic happened on the source database, and maybe you want to catch up with that in between the initial copy and the current point in time. But that's not possible with dump and restore. And all in all, with all of that in mind, internally at the job, when we were tasked with some migration projects, I began writing a doc about all the best practices that I knew about around all those topics. But then it was a lot of concepts to write down, and instead I wrote pgcopydb. So you can consider pgcopydb as being basically an implementation, a standard implementation of all the best practices I've gathered along the way in the past, let's say, 18 years on the topic of moving data around from one Postgres instance to another. It's fully open source. It uses the PostgreSQL license. It's fully available on GitHub. That's where we handle the source code, but also the project itself. So you can open an issue. You can contribute by opening pull requests. You can open discussions, etc., etc. And you're welcome to do so. So just hop over to the GitHub link on the slide. If you go there, you will see that there is a README. So you have like an introduction to the project. The README is not the documentation. There is a full documentation associated with the project at the second link on the slide. And from the README, of course, there is a link. You can follow it. Please have a look at the documentation. Please read it. After all, I have spent a lot of time writing it myself. So the least you could do is read through it. How to copy a Postgres database? Well, then, now that we have pgcopydb as a tooling, instead of doing the pgdump, pgrestore, or the other command lines we saw before, what you could do is pgcopydb clone. And if you want to, you could also say that you want a concurrency level for the table data sections, or of 4 at a time. And maybe your target system is having a lot of CPUs available for the task, and you want to use 8 of them for creating indexes in parallel to one another. pgcopydb clone implements the full operation in 10 steps. It's some of the steps are in series, and some of the steps are running in parallel to one another. So it's more of a logical way to look at it for us humans to understand what's happening. It's not exactly happening that way inside the code, but that's a proper way to look at it. So pgcopydb, the most important thing on that slide is that, yes, pgcopydb actually uses pgdump and pgrestore. It does not entirely replace them. It uses them for the schema parts of the migration, and it skips them and handles the data parts itself. So first, we're going to dump the schema with the pre-data and the post-data sections of them. And then pgcopydb queries the catalogs to get the list of the tables and indexes and schemas and stuff that you want to move over to the new database, to the target system. Because pgcopydb implements its own easy-to-use filtering abilities. And step 3 is about restoring the pre-data section, so the schema, create table, etc. And it does apply the filtering using the pgrestore advanced API for it, which requires having the OID of the catalog objects. That's why step 2 is querying the catalogs. Step 4, we can copy many table data at the same time. That's the table jobs concurrency. So it was 4 on the slide before, it might be 12 or whatever number you want. And that many number of processes are started at once, and then they just share the workload in between them. In parallel to that, there is another process, an auxiliary process, that is going to walk through all the large objects that you have defined in your system and move the large objects data from the source to the target server. As soon as the table data part is done for one specific table, then there is one of the concurrent create index processes that is signaled, and it is going to create an index for that table. The idea is that we will create all the indexes for the same table in parallel to one another, and that includes the primary keys. So to create a primary key with some good level of concurrency, what you can do is create unique index. And when the index is ready, then you can use alter table, add primary key using index. And the index has already been created. So the alter table operation is fast. The other way to do it, like pgrestore does, prevents concurrency in creating the indexes, because alter table is an exclusive lock and you won't be able to create the other index concurrently. So we have a trick in pgcopydb to be able to concurrently build indexes, including primary keys and other indexes for constraints. Then we run vacuum analyze on the tables before handing over to the next step for your application. And at the end of the copy, we sync the sequences. And again, we have an auxiliary process that walks through all the sequences that you have and does that in parallel, concurrently to the rest of the tasks. When everything is done, we can restore the post data schema, which is what pgdump is calling the post data. And pgrestore is happily restoring that. It includes the views, the procedure functions, materialized views, etc., etc. About the concurrency in pgcopydb, what you can see is that we bypass intermediate files for table data, and yet we have some good level of concurrency to it. Internally, pgcopydb implements the copy protocol, and it receives buffers from the source database and sends them over to the target database, as simple as that. pgcopydb builds all the indexes in parallel, concurrently to one another, including the constraint indexes, like we said in the previous slide. And we also have support for same table concurrency. So you can define a threshold, and any table that is larger than that is going to be split in chunks using a where clause over an ID that is an integer value. But it's all automated. You just, as a user, have to say what is the threshold, and pgcopydb figures the rest for itself. Again, using catalog queries. pgcopydb has more features compared to dump and restore. pgcopydb tracks operations and is able to resume after interrupt. The tables that were copied in full are just skipped the second time. And if a table was, a copy was interrupted, then it started again from scratch. Compared to dump and restore, we also do the copy phrase and vacuum. And we have support for roles. For roles, we actually call into pgdump all, like you would manually, but it's included in pgcopydb, and you can choose to migrate your roles with or without the passwords. If you want to migrate the passwords, you need to be super user when you connect to the source system and also to the target system. And so there is a trick to separate that away from the rest of the operations, and we're going to see that in the next slide. And for the same kind of super user connection privileges, there is a way to skip extensions and collations too. And here is what it looks like. You grab a snapshot in a concurrent process. Coproc is a bash tool that allows you to run a process in the background. And then we can copy roles and extensions, typically using a super user connection string. So if you're using a cloud system, usually they allow you to do the roles and extension without being super user, so you wouldn't typically need that. But on-prem, you do need to be super user to migrate over the roles. So you could do it on your own separately, but you can also use pgcopydb copy roles. This command will do exactly just that, and that command could be used with a super user connection string. And then you can do the same for extensions. And now the rest of the system, it doesn't need to be super user. So you could use pgcopydb clone, but then you need to say that you want to skip the extensions because you've done it before already. And so is all there is to it. So now that you have this tool to handle most of your tasks that are linked to migrating or copying a database over to another server, here is a pro tip of the trade. Migrate your CI first, your continuous integration setup, so that you can test that your code is actually running on the new system and the new PostgreSQL version, etc., etc. If you do that, what you achieve is automated testing for your migration project, which is very nice to have. And that's called continuous migration. I wrote a white paper about that some years ago that you can still find on pgloader.io. The next step that people always ask about is what about change data capture? The idea of change data capture is that, let's say that, so the timing of the initial copy is going to be bound to the size of the data. So if you have a couple terabytes of data, maybe it takes a couple days to move the data around from the old to the new server. And maybe you don't want to shut down your application for those 2 days. So what you want to be able to do in some cases is do the 2 days of the initial copy that you need to, but during this time you capture all the changes, the insert, update, and delete traffic that happens on the source database in a way that you can replay it on the target instance. Beware that I call that expert mode only. So always try to do a migration without change data capture enabled. You do that first, and then you have an actual migration timing that you can talk about and understand and see if it's a blocker for your migration project or not. Because change data capture makes everything more complex. It's impossible to test the target database, or at least it's limited to read-only. There is a non-trivial impact on the source database because of wall retainment on the PostgreSQL source side. And then you need to synchronize the cutover point for the application, and also when you stop to apply the change data capture. The database migration complexity or budget usually lies into those 4 points that are illustrated on the slide. You need to migrate the data. You need to migrate your application code. If you change PostgreSQL Major version, that's it. Yeah. Then you need to migrate the service. And while you're doing that, you're not doing anything else like product development, marketing, etc. So you might consider the opportunity cost of this project. But when we focus on migrating the service, in a lot of cases, we are trying to solve the wrong problem. It's easy to focus on migrating the service and how to mitigate the downtime window. But it's rarely the most interesting problem to solve. Usually the most interesting problem to solve is about migrating the code, because you need to test and validate that everything that used to work on the old system is still working fine on the new system. And that's time consuming, and it requires proper processes around it. So I encourage you to focus on that part of the migration. That's why I was mentioning the CI and etc. But if migrating the service then turns out to be quite of a problem, because you have 2 days of copying the data over the network from the old system to the new system, well, then I get you. I understand. Sometimes you actually need to implement change data capture. When using pgcopydb, you can do that by just appending the -- follow command line option to the command line. So you would do pgcopydb clone -- follow, and that implements change data capture for you. That's all you need to know about it. It's not exactly all you need to know about it, really, because when you implement the follow mode, well, then at some point in time, you need to implement a cutover. So you need to be able to say, hey, I don't want to be replaying changes anymore to the target system. And you do that with the command pgcopydb stream sentinel set end pose, like the end position on the wall that you want to stop at. And usually you do that at the current time when you run the command. And when everything is done and you're happy with it, you can clean up the source and the target database. Here is the steps that we implement for pgcopydb follow. So we need to grab a snapshot. It's done entirely within the command, within the pgcopydb clone -- follow command. This command is going to grab a snapshot for you and then share the snapshot with all the concurrent processes that you are running. One of those processes is going to set up logical decoding with the replication slot on the source server and the replication origin on the target system. It's going to run the initial copy of the data, which is to say the 10 steps we saw in the previous slide. Then it provides you with it's using the remote control stuff that was mentioned before to enable applying the changes after the initial copy is done and only after that. So for a while, concurrently to the initial copy, we do not apply the changes, we only prefetch them. So we still consume from the replication slot in a way that we try not to fill in the disk with the wall on the source system. So we still need to consume the wall files. So that's done by pgcopydb. It's called the prefetch mode, and it turns to prefetch and applied, prefetch and catch up, only once the initial copy of the data has been finished. When you implement the cutover, it's step 5 in that list. The cutover, before getting out of the command, before finishing the command, pgcopydb will resync the sequences manually for you, because logical decoding in Postgres doesn't include changes to the sequences. So we manually resync the sequences. The pgcopydb clone -- follow command, or pgcopydb follow is another spelling that you might want to use, is going also in step 6 to clean up the resources that were implemented for change data capture. And in step 7, we stop holding the snapshot. pgcopydb uses PostgreSQL logical decoding, the low-level API that is available in Postgres, to implement change data capture. And it's compatible with both the test decoding plugin, which is part of PostgreSQL core. So if you have PostgreSQL, you already have the test decoding plugin. And some people prefer to use Wall2JSON, and pgcopydb has been made compatible with it too. It basically implements 2 modes of operation. The one I mentioned before, prefetch and catch up, which is necessary for the initial copy. And again, if the initial copy lasts for 2 days, you really need to be prefetching the changes and then catching up with the changes only after the initial copy is finished. But once you've caught up with the stream of changes, the prefetch and catch-up technique introduces a lot of latency. So you want to switch to a live replay mechanism. Well, pgcopydb just does that. So it's going to automatically figure out that it's caught up with the changes, and switch to live replay, where it doesn't need to wait for a full file to be prefetched entirely before trying to catch up with it. It's just going to replay everything as it goes. And you can remote control everything with the Sentinel table with a bunch of commands that are documented and that we saw in the slide for defining the cutover point, for example. Change data capture with logical decoding in Postgres also comes with some limitations. And pgcopydb shares those limitations with Postgres. You need to have replica identity on all of your tables. I encourage you to read the PostgreSQL documentation about that, or the pgcopydb documentation about it. And DDLs are not replicated. The thing with DDLs, though, DDL is schema changes, alter table, create index, stuff like that. In terms of the context of the application, what it means is that you're upgrading the schema. You're changing your application from one version to the next. You really want to be doing that in the middle of a migration project. I don't believe it's the better way to do it. So the fact that we do not support DDL, I don't see it as a limitation really, but yeah, it needs to be listed there. If you need the sequences to be updated concurrently to the change data capture, PostgreSQL is not doing that. So you can use the pgcopydb copy sequences concurrently to the main command as many times as you want to during the follow mode, if needed. And finally, we have support for large objects in the initial copy parts of the replication, or the copying, but we do not have support for it in Postgres itself as part of logical decoding. Large objects are not part of the logical decoding API. So pgcopydb will not implement change data capture for your blobs. In conclusion, how do you copy a PostgreSQL database from one PostgreSQL instance, the source, to another one, the target? Well, you just use pgcopydb clone command. And if you need, after you have done that, and you see that you need to mitigate the runtime window because you've done the pgdb clone more than once, and it's troublesome, you can switch over to using pgcopydb clone -- follow if needed. And that concludes my presentation. Thanks for your attention.